Today we'll begin with Kubernetes. Okay, let us learn about container orchestration with Kubernetes. We have already learned one container orchestrator tool, right? Docker Swarm. So Docker Swarm has got limited features or it's not as efficient as Kubernetes. Kubernetes has got all the advanced features and it can also help us achieve zero downtime during the rolling updates and rollback. So let us deep dive into Kubernetes. First, let us understand some basic differences between Swarm and Kubernetes before we jump into the architecture and the rest of the things. Both are container orchestrator tools, meaning which can manage containers on multiple servers, right? It can manage containers. But the Docker Swarm can manage only Docker containers. Whereas Kubernetes can manage containers from any runtime. Like we have learned when we are learning Docker, like it has got different container or there were different container orchestrators like Docker, right? Rocket, LXC, Creo, and so on. So there are different container runtime. So Kubernetes can orchestrate containers from any runtime, whereas Swarm can manage only Docker containers. That's one of the differences. And Swarm is very easy to learn. Commands are same as the Docker commands. But Kubernetes, the learning curve is steep. You have a lot of things to learn here, right? And the Swarm commands are very simple, like Docker Swarm commands, and setup also. You don't need to install Swarm separately. If you remember, we just initialized it. Do you remember that? We did Docker Swarm in it so that you can run containers in the Swarm mode, right? Whereas Kubernetes setup is completely different and the setup varies from environment to environment. Like on any cloud, the setup would be different, whereas on-prem, the setup is different. So the setup varies from environment to environment, and it's only the setup that varies. Okay, the concepts, the commands remain same, be it on any environment. That is another difference. And architecture. Swarm has got a very simple architecture. Again, Kubernetes architecture, like it has got so many moving components. And yeah, that's how the architecture is. Many components. It has got many components to understand. What else? And yeah, in Swarm, you don't have auto scaling. You have to have additional scripting and all. Here also, you need to configure it, but auto scaling possible in Kubernetes. Okay, and you have rolling updates and rollbacks. What are rolling updates and rollbacks? What is a rolling update?
Releasing the new version.
Yeah, suppose you have deployed some application version 1, you want to upgrade it. During upgrade, there might be some maintenance scene, right? There might be some maintenance scene where the application would be down. But upgrading the application without downtime, that's called zero downtime. Zero downtime is possible in Kubernetes, which is not possible with Swarm. Right, these are all some of the basic differences. When we get into the architecture, when we really start working with Kubernetes, you will see many other differences practically, right? So, yeah. Let's get into the architecture of Kubernetes. Now, see, the basic thing is same. Like they maintain high availability, they maintain load balancing of containers on the cluster. All these basic features or basic things are same. Okay, the difference comes in their architecture, their performance, and so many other things. And also, Kubernetes prefers declarative approach. What is declarative approach? Swarm, we use imperative approach. Imperative approach is you write the single line commands, right, to perform the task or to execute the task, right? Kubernetes also, you can do everything with single line commands, but Kubernetes prefers declarative approach where you define your desired state or expected state in a manifest file. Those manifests are written in either JSON or YAML. YAML is more famous. That's how you define the Kubernetes configurations. These are some of the differences, basic differences. Okay, once we get into the architecture, we can understand many other differences practically. So let us get into the architecture of Kubernetes. Can you all see this architectural diagram?
Yes.
So yeah, this is the Kubernetes cluster. Like we already learned what is a cluster. What is a cluster, by the way? Anyone?
Group of hosts perform particular task.
Group of Docker hosts. What is a Docker host?
Nodes
What is the mean by Docker host?
where Docker services are.
A VM or a server where Docker is installed and Docker is running a group of Docker hosts. So this is the group of Docker hosts. And out of this Docker host, one would be acting as a master node, like a manager in Swarm. See, this is the manager node. Okay, and the rest of them were called as worker nodes. So this is your control plane is called the master node. Okay. And these are called the worker nodes. This is the worker node. There's another worker node. You can have any number of worker nodes, right? These are called worker nodes or simply called as Kubernetes nodes, or they were also called as minions some time back. But yeah, and each worker node or master node has got different components. Let's deep dive into those components. If you take a worker node, there were different components. The first one is like Docker. Okay. Second one is the kubelet. Third one is the kube proxy. So let us look into these components first. What is the Docker? Docker, oh, as you know, it's a container runtime, right? Container runtime is like a suppose on the worker node you want to run, you want to deploy your applications, containers would be running. So obviously Docker runtime is needed. That's the first component. Docker should be installed on running on every node, right? That's the first component. Second component is called the kubelet. Kubelet is called the Kubernetes agent running on the worker node. Means your master should interact with the worker node, means it would be talking to the kubelet. Kubelet is the Kubernetes agent running on every worker node. Kubelet is a component with which your master node will interact with. All the instructions, everything would be given to the kubelet. So that's the second component. Third component is the kube proxy, which will take care of all the networking of your cluster, like how the containers on different nodes will communicate, how different nodes will communicate. All of this communication will be handled by the kube proxy component. Are we good? Yes.
Yes. Yes.
So those are the first three components: Docker, kubelet, and kube proxy. Then comes something called pod. You can see here, this is the pod, right? What is a pod here? In Kubernetes cluster, you will never see container like this. What does it mean? You will never see container like this. What does it mean? You will never see a container like this. Always in a Kubernetes cluster, your container would be wrapped around with a layer called pod. See, your container would be wrapped around a layer. You will never see container without this layer. And that layer is called pod. Pod is like a home for your container to live, right? It's like a living environment. You see a chocolate with a wrapper, right? That's a pod, right? Pod is like a layer where a container lives. You will never see container without the pod. Always your container will be wrapped around the layer called pod, right? And every pod will be assigned with some IP address, some network, and everything. Your container will be sharing the same pod network, same pod IP, and so on. Got it right, everyone? So that is your pod. And every pod can have a container in it. Like generally one container per pod is the best practice. You can have also multiple containers. So that's a pod. So that's why from now onwards, we will not tell container is running. We'll say pods. Okay. And pod is the basic and the fundamental unit of deployment. Means basically in a Kubernetes cluster, you deploy the pods, you scale the pods, you delete the pods. Basically, you work with the pods. That's a basic or the fundamental unit. You don't say deploy a container. No, you deploy a pod. Right? Understood, everyone?
Yes.
Yes, yes, yes.
So that's a fourth component, Docker, kubelet, proxy, and the pods. These are the components which runs on the worker nodes. Now come to the master node. See, master node is also called as a control plane of the entire cluster. That's a decision maker, right? And this control plane has got different components like API server, scheduler, controller manager, etcd, and so on. These are the different components. Let's look into the first component, API server. API server is called the core component of the cluster, right? That's what which will validate the manifest file. Means you write the manifest file, right? Like I told you, we put the configurations in the declarative approach. You write a manifest file with all the configurations of how many pods there, how many containers there, and so on. Right? You write the CLI commands like Kubernetes commands, or else Kubernetes has got user interface also through UI or through CLI through manifest files. You run those configurations, means you are feeding the API server. They are fed to the API server, or else API server will take those and validate them. Means will understand them. Once those configurations are correct, it will talk to other components like scheduler. What is the scheduler? Scheduler is the as the name says, it schedules the pods because that is the one which decides which pod should be running on which worker node at what time. This kind of scheduling will be done by this scheduler component. Okay, scheduler will talk to those, will schedule them to the worker nodes. Okay, and then comes controller manager. What is this controller manager? Controller manager is the name says it will have so many controllers like replication controller, endpoint controller, pod controller, node controller, replica set controller, deployment controller, and so on. Basically, those controllers will have some watch loops, unending watch loops, or else non-terminating watch loops, which will keep on running and which will make sure the actual state, or else the actual state of the cluster, means actually what is running is as per the desired state that is defined in the manifest file. Desired state means expected state. In the manifest file, you might be writing we need 4 pods, but in reality, there were only 3 pods. So it will compare the actual state with the desired state. If there is any deviation, this controller manager will put them back in place. Right? That's how the scheduler controller manager will work. And then comes something called etcd. Okay, before going to etcd, understood the scheduler and controller manager? Controller manager will keep on running this non-ending watch loops. If any deviation is there, it will inform the scheduler. Scheduler will schedule the pods accordingly. Isn't it? Scheduler is the one, okay, controller identified some deviation. It will inform the scheduler. So scheduler will decide it should start a pod on worker 2. Then it will talk to how they will talk. They'll talk to the kubelet. That's what I was saying, right? Your control plane will give instructions to the kubelet. Kubelet is the Kubernetes agent running on every node. As per the instructions, it will deploy the containers on the cluster. Got it, everyone? Right?
Yes.
Yeah.
So yeah, scheduler will talk to those components and perform the task. And then there is something called HCD. What is HCD? HCD is like a key valued store. Key valued store means where data is stored in the form of key valued pairs. Key value store or NoSQL means all the cluster information will be stored. Because see, we were talking about, okay, scheduler is deciding on which node it will deploy. Controller manager is comparing actual state with desired state. How does controller manager know all this information? Or else how does API, or else how does scheduler know? It is deciding on which node what should run. Means the scheduler should have the details, right? Like, okay, how much resource available on worker one, how much CPU, how much memory, or what is actual state. How are these components getting all the details? From HCD. HCD is like a storage, NoSQL database. It is data will be stored in the form of key valued pairs. If API server is considered as the brain of the cluster, HCD is considered as the memory of the cluster. Understood? This is called memory. API server is called brain of the cluster. Understood? So yeah,
Yeah.
API server will validate and it will give information to scheduler and controller manager. Controller manager will check the resources, will check the actual state. It grabs the information from HCD and accordingly deploys the pods on the cluster. That's how these components work together to manage your cluster. Understood the architecture, everyone? Any component, any questions?
Yeah, confusion between API server and HCD.
API server is the one which will validate your inputs. Like you will be deploying some pods, you write some configuration files, right? Those are validated by the API server component.
Okay.
API server is the one which validates it, which understands this. And if it finds the file is all good, it will interact with other components to deploy. Other components will get all the information again from HCD.
Okay.
Clear?
So all manifest everything will be in API server, yes, right?
Huh?
Return manifest all returning that is in API server.
That is not
That
API server. You write the manifest files, you run the manifest files. Those manifest files are validated by API server. Not that your files are in API server. They're validated in the API server. They're validated by API server.
okay. Got it.
So Preeti, this networking IP address assignment, then routing between worker nodes, all done by proxy.
Yes. They're all done by proxy networking.
To external connectivity, how that is performed, how the mapping happens
Sorry.
from public to for if node wants to talk to,
Mm.
if it wants to send information to external world like internet and all, how
Mm.
that traffic is allowed.
The proxy will take care of it. How we will do, we will see with the hands-on.
Okay.
Any more queries?
As we have seen in Docker, we have a IP address for container, and in this architecture, we could see there are multiple containers in a single pod. We will be having each IP for individual container, or it will be an IP for a pod.
It will be IP for a pod and each container will be accessed on the same IP with a different port number. Any more questions? So we were talking about the architecture and different components, right? Let us talk about the setup now, like the Kubernetes cluster setup. Kubernetes cluster setup, like Kubernetes setup varies from environment to environment, I told you, right? The first thing is on-prem, maybe companies may have their own data centers. So they want to deploy on their own premise. On-premise. The second one is on cloud. It might be AWS cloud or else Google Cloud Platform or AWS or Azure, or it can be anything, right? On the cloud, you can set up. So coming to the first kind of setup, on-premise kind of setup, this is the most complex type of setup. Okay, where you will install or you will take care of all the components from scratch. Like you will be taking care of API server, kube proxy, kubelet. You have to install all of them and see they were all working. That's a raw method from scratch, the complex way of setting up your cluster and managing your cluster. These are all done from your end. Everything you have to take care of it. Okay, that's the first thing. Next one, GCP, Google Cloud Platform. Google Cloud Platform offers a service called GKE, Google Kubernetes Engine. And using this service, you can create a cluster with a single click. The easiest way of creating a cluster and all the cluster components, like this service is absolutely free. GCP provides this for free because Kubernetes is initially a product of Google. It is from Google, now managed, but now it's managed by CNCF, Cloud Native Computing Foundation. So Google offers this service like a pre-package with a single click. You can create production grade clusters and it is free. That's another way to set up your cluster. The other way is through on AWS. On AWS, again, you can do the setup in multiple ways. There is something like Kubernetes operations with which you can set up the cluster. Okay, but yeah, that's not so effective or efficient. In real time on AWS, we'll be using a service called EKS, Elastic Kubernetes Service Managed Paid Service. Okay, with this, you can create a cluster. Cluster setup is not so easy or not so complex. It's a moderate. You need to know many other components here, but this is very widely used. Out of 50% of Kubernetes clusters are EKS clusters. EKS has got a lot of demand. It's a paid service of AWS. That's like I told you, right? 50% of the clusters in the market are EKS clusters. So you can imagine the demand it has got. And then coming to Azure, Azure also has got some service called AKS, Azure Kubernetes Service. So yeah, every cloud provider offers a service. Setting up the cluster on cloud providers on cloud is more easy than doing it on on-prem. But to understand the setups on cloud, if you have to understand this setup or this one, you should first understand this on-prem kind of setup. So in this course, we'll be starting with this on-prem kind of cluster setup. But we don't have our own on-prem servers. We don't have our own data centers, right? So what we will do, we will again use some instances on AWS. Like we'll use some EC2 instances from AWS. But we will not use any of these services. Rather, we use those VMs as, like we assume those EC2 instances as a bare VMs and we'll start the setup. Okay, and also here we'll take one more advantage. There is something called Kubernetes. It is again a utility or a tool with which you can set up a cluster on on-prem kind of, right? Like rather than you installing API server, etcd and all manually, you can use this Kubernetes utility with which you can spin up your cluster, right? So that is what we will do. We can use Kubernetes on any on-prem kind of. So here we'll use the benefits of Kubernetes and set up our cluster, assuming those are raw VMs. So once you set up this one and once we do the hands-on, once we complete this hands-on, there were some features will be missing here. Of course, on-prem, no features you will miss, but with the kind of setup we have limitations like we can't see certain features of Kubernetes. Those features we will execute on EKS, right? Means we will learn Kubernetes completely on this on-prem kind of setup. Whichever features missing there, we'll go for EKS and do this. Because whether you set up a cluster on on-prem or GCP or AWS or anywhere, the other features, the manifest files, commands are same. right? They are no difference. Whether you learn on-prem or EKS commands are same, but the way the cluster architecture, those architectures and how the clusters manage those things varies. We'll discuss them, and whatever features we can't see with the on-prem, we will see them on the EKS. Are we good?
What about mini cubes?
Minikube is never used, it's for learning purpose. It's a single node cluster. Like if you want to try out, if you want to learn, Minikube can be used. It's a single node cluster, means you will just have one node where everything will be master, worker, everything will be considered as a single node cluster. For testing or for learning, you can use it. You will never see it in real time. Like I said, whether it's a Minikube or whether it is EKS or whether it is a on-prem cluster, commands are same, concepts are same, manifest files are same. Setup differ.
What is COPS here in
Kubernetes
EKS?
operations, some service with which you can create a cluster, but even that's not used in real time.
Okay, so you mean to say that COPS features cannot get in the GCP?
COPS features cannot get in GCP.
Uh,
COPS is a
means
AWS service. You will not have COPS in GCP. You will not have GKE on AWS. That's a service on AWS.
oh, it is a engine, Kubernetes engine.
Huh?
Oh, in the same GKE is a Kubernetes engine,
It is a
correct?
service on Google Cloud Platform, Google Kubernetes Engine. That is a service on Google Cloud. Like you have EC2 service, S3 service on AWS. That is
Uh,
a service on Google Cloud.
oh, in the same way, COPS also.
Yeah. COPS on AWS.
Okay, different naming term. That's all.
Okay. Let us get started with the setup of Kubernetes. Like we will take some instances on AWS, assume those are the EC2 instances, or sorry, assume those are the some VMs, and we will be using Kubernetes and set up the cluster there and get to the hands-on. And then once we learn this cluster completely, whatever features we missed, we'll get onto EKS. Is the agenda clear for everyone? Any questions from anyone? Good to go?
But again, we are setting up cluster in EKS, right? With all the configuration. Then those missing features will be demonstrating in the EKS.
Yeah. Yes. So let us now create a cluster, an on-prem kind of setup. This is gaining a lot of demand these days. And because companies, particularly startup companies, when they understood or when they realized the cost they were incurring on these clusters, they were planning to have their own clusters, like the clusters on their on-prem. So person with on-prem kind of setup knowledge is gaining demand these days. Of course, it's quite complex. So people with this knowledge will have more opportunities or great demand. So yeah, I'm choosing Linux 2 instances, t2.micro 2 instances with a key AWS. Okay. And I would like to add all traffic for them. Yeah. Adding a security rule by allowing all traffic. Okay. From anywhere. Here, source type anywhere. Okay. Let us launch. Oh, I might have chosen 2 instances. Let me launch one more. One second. This is the one using launch wizard 25. Let me launch another instance with the same security rule. Amazon Linux 2, T2.micro, AWS key. You can put the same name. So you should choose this one. Select the existing groups. Here we can browse the name we have, which is 25, which is created just some time back. Launch. And let me say it's a Kubernetes master.
Any specific reason for allowing all the traffic at the beginning of at the launching of the instances?
You can do it later also or now. Anything is fine. The reason for allowing all traffic, they should communicate. You should be opening quite a number of ports for the nodes to communicate. So I have added all traffic. You can do it now or you can do it later also fine. And let's connect to the master. And this is going to be the master. Let me also connect to the worker node. Okay, this is the worker node. Okay, this is the worker node. And this is the master node. Good. Now follow the steps. Give me a second. This is the one architecture diagram. You can go to your drive. Okay, you have all the commands available there. Like, just a second. You have all the commands available there for the setup, including each step of what are all the things we were installing here. You have all the commands in there. Follow the document and set up your cluster. Okay. First thing is, first let's switch to master. You have to do this setup very carefully. Okay. Things may mess up, correcting it or fixing the issues may be a bit troublesome. So do it very carefully. So first thing is, just a second.
Under which folder we could see those commands?
Kubernetes folder. You have different folders in your drive, correct? So how are you using till now? For each tool, you have a separate folder. Same is the case. So first, let us set up the host name. Like host name set master node. I'm trying to set their host name. It's not mandatory, but a good practice is setting their host names accordingly. The worker node, I want to put like a worker node 1. Okay. What is that? Okay. You should be a root user to do this. Okay. So done. Host name is set up on both of the machines, and these machines should resolve their host names with each other. So go to HC host file. Here they should resolve their host names with each other, meaning put the private IP of the worker nodes. Put the private IP. This is the IP of the master. Okay, and the host name of master. Similarly, private IP of the worker node. Okay, so they should resolve their host name. I'm placing those entries in the host file. Let's save this. And okay. So done. This is the second step. Next thing is we are using Linux to Amazon Linux 2 instances, right? Which are CentOS or Red Hat based systems. For these systems, security on Linux, security Linux, SC Linux, that's called SC Linux, should be disabled. By default, it's enabled, but for the nodes to communicate, we need to disable it. So set enforce to 0. That will disable SC Linux. Do you see that? So do that on the other node as well. Okay, done. And what else? Yeah, that's all. So we have made changes to SLNX. We made changes to their host name. So for all the changes to get in effect, restart the machines. It may take a minute to restart. Let all the changes get updated.
Now, Preethi, in real time, the DNS is taken care by, like, while mapping the DNS server, right? It will take, because we need not have to mention the etc host.
If the mapping is not done, you have to. If it is done, you need.
If you mention in etc host file, it will be faster than DNS. If you mention in the etc host file, it is faster than DNS.
It is fast of the, sorry, louder.
Faster than DNS.
It's not like a faster, or it's just we are changing the host name. The other node should understand, or should, whenever you say it's a master hyphen node, it should understand the machine. So we are doing this mapping so that it can understand. See, we are able to log in and the host name got changed on the worker node. Do you see that? So here updated. Now here also. Let us try. Okay, meanwhile, now once the systems are back, we shall install the components. We will need 4 components here. Like the first component is the Kubeatom. Kubeatom is a utility with which you can create your cluster. That's one thing. Second thing is Kubelet. Kubelet should be running on every node, right? We need to install this as well. We need 4 components. Kubeatom. Okay, utility to create or to manage your clusters. And then we will need Kubelet. Kubelet should be running on every node, which is the Kubernetes agent with which your API server will interact. And then Docker should be installed. We know Docker runtime should be there. Kubeatom, Docker, Kubelet, and yeah, and one more thing is kubectl. Kubectl is the command line, Kubernetes command line utility. Means you want to interact with the cluster, means you should run some commands, right? So how do you interact with the cluster? This kubectl is a component which will help you interact with the cluster. The cluster might be created on any cloud or on-prem. kubectl is mandatory. Means to interact with the cluster, you need this utility. Okay, those are the things we need to have. Now let me try connecting. Okay, it's done now. See, you see it is updated. So on both the machines, let us install these components. But you don't have these components in the yum package manager by default. So we are going to create a Kubernetes repository file. If you remember in the beginning, we have seen, right, yum.repos.d. Here you have repository files. You also created Jenkins repository file, correct? Similarly, we are going to create Kubernetes repository file from where we'll download the components. See, cat till the end of the file, read till the end of the file and put it in this file called Kubernetes repo. See, Kubernetes repo is there from where it should download all the packages. Okay, do the same on this machine as well. Okay, file might have been created. Now let us install the components using yum. So we'll install the components. Just a second. Okay. It is in the yeah, once these components are installed, let us install Docker, kubeadm, all of this. See, this is the command. Yum install Docker, kubelet 1.21. Install a particular version for their compatibility. Go with a particular version of it. Okay. So do the same on the worker node as well. In start kubelet and Docker. Once they're installed, start and install. Right, start Docker and kubelet. Also enable the Docker and kubelet. Enable the components. Right, done. So yeah, all the necessary components are required. Once they're all done, now you can initialize or start your cluster with a kubeadm command. That's what is kubeadm. So kubeadm init, like you did swarm init, API server, advertise. Okay, here you should put the IP address, private IP of your master. This is the private IP of the master. Okay, you are telling that cluster should be started with this node as a manager. And every pod will have an IP and network, I told you, right? You can assign some pod network range for your pods, some default range I'm assigning, and ignore pre-flight errors. Means, see, the eligibility to create a cluster is each node should have minimum 2 CPU and 2 gigs of memory. But we were using T2.micro, which will have only 1 CPU and 1 gigs. So it will not allow creating a cluster. So I'm ignoring those errors for memory and CPU. For our lab, that is enough. So run this command. See, there is some error. API server. API server. Advertise address. Actually, it's not advertise. It was advertise address. Unknown flag. It was saying this flag is not known. Advertise address. This should create a cluster and it will give us a token. which you need to run on your worker nodes to get added to the cluster. Let it finish.
Instead of IP address, can we use host name?
You can use. See, cluster control plane is getting ready with all these components. Do you see Kube API server, kube controller, manager, scheduler? All the components are getting ready. And cluster is ready. See, your Kubernetes control plane is ready to start using the cluster. See, we have created a cluster as root user. But it is always good practice to manage your cluster as a regular user, not as a root. But before we do that, it is saying join any number of worker nodes with this token. See, if you see they were connecting to master on this port, means you have to open this port on master. That's why I have added all the ports, because as we go by, there were other ports needed. So I have added all the traffic. But good practice is you should add only these ports whichever required, right? Like now take this token and run on the worker node. And it will be connecting to the master by communicate on that particular port. Meaning it's not copied correctly. Right, so it is connecting. Yeah, see this node has joined the cluster. You can run this command on the control plane, any commands on the control plane only. So you may run the command here, or else it was saying you need to connect as a regular user. So switch to root, switch to regular user. But before that, whenever you create a cluster, see under HCD Kubernetes admin.conf file is created. You can see that HC Kubernetes admin.conf. Read that file. See, this is having all the cluster authentication tokens, certificates to connect to the cluster. Any user, okay, to connect to the cluster should have this file. So these are the commands you need to execute as a regular user. Let's say as a root, as a EC2 user. Create a directory called .cube. Okay, and then copy this admin.conf file into .cube directory as a kube config file. Then any user can have connected to the cluster. Means remember, to connect to any cluster, you should have the kube config file. That's what we were doing. See here, we have what the first command did, created a directory called .cube. So in this home directory, created a directory called .cube. In this .cube, we have copied admin.conf, okay, which is created as a root user into this config directory. Config file. That's called kube config file. Understood? Kube config file means a config file in the .cube folder, which is created by default. All right, so cluster is ready. We are able to connect. Get nodes will show you the nodes of the cluster. How many nodes do we have? 2 nodes, right? One is control plane, another one is worker node. but they were saying they are not ready. They were connected, but for them to communicate, you need to install a network plugin. There were so many network plugins available. One such is Calico network plugin. This is officially available. Okay, it's applying some default manifest files. You will understand these commands later. Just install Calico plugin. Okay, that should install the plugin. And now if you see get nodes, in few minutes, status should be changed as ready. What happens, do you know? We have installed API server scheduler, everything, right? All of them will be deployed as a pods in the cluster, isn't it? You install anything on a cluster means how do you install as a pod? See, they were all pending. That's why, see, some of them, core DNS. Do you see here Cube API server, controller manager, Cube proxy, the components which we have discussed will be running as a default pod. Those are all pods. See, because Calico plugins are still in the container creating state. Once they were ready, your cluster nodes will be ready. Yes. Now all the pods are in the running state. Now you get the nodes. Yes. Do you see here? That is the backend. Means that's what is happening at the backend. Clear, everyone? Understood? So cluster with the 2 nodes are ready, default pods are running, means your cluster core components are deployed. Now you can deploy your applications like address book or PHPDB or whatever you want.
You install this only on a master, right? That Calico.
You are running the commands from master. It's not that you are installing on master. You are running those commands on master. They'll be installed on the cluster. It's not that they are installed on worker or master. They are installed on the cluster.
Okay.
Pods are running, right? If you want to see where they are running with output wide, all the pods. Here you can see. Can you see that? They were all, some of them are on worker node, some of them are master node. Do you see that? So it's not important. Do you remember swarm concepts? It's not important where they are running, right? For you, it's important whether they are running or not. So you need not bother about whether it is installed on worker or mass. It's installed, they are installed on the cluster. They are cluster-wide components. Good.
Okay, good. You mean these are the pods, right?
Yes.
Calico.
Right. So now let us deploy some pod in the cluster. Actually those are the default pods. You can run kubectl get pod. You don't say anything. Okay, I will create a pod. Kubectl create pod name sample pod from image. I want to, you see your what is inside the pod? What is inside the pod?
Containers.
Container. How is container created?
With images.
And that's what I wrote. Okay, image is Nginx. It will search for the image on Docker Hub. It will pull the image and it will start a pod called sample pod. Let's see. Unknown flag name.
I'm seeing blank screen. Is it
Huh?
for everyone?
Louder,
seeing
please,
blank.
louder.
I'm seeing blank screen. Is it for everyone or me? Okay, now it's come.
Are you all
No,
seeing a blank screen?
no,
Why?
we can see the screen.
No.
Okay, Preethi, go ahead. I think it's a my network.
Yeah, that's okay. So kubectl, please check, okay, check other windows. Kubectl run. I want to start an image, so start a pod. Command is sample. Image is Nginx. Okay, kubectl run. The run means it will create a pod. It's not create pod, it's kubectl run. Pod name is sample. It is coming from image Nginx. Let's see. See, it says pod sample created. You can check the pod with kubectl get pod. See, it's still in the container creating because pod means inside that container should be started, container should be created. See, soon it went to running state. Do you see that? So your pod is ready with a container in it. Okay, but where is it running? If you want to see that, run with the output wide. Obviously, it is on worker node. See, remember on Kubernetes cluster, your pods will be deployed on the worker nodes only. Master will not run any pods. That's a default behavior. In Swarm, do you remember everything goes to master worker? Later on, if you want, you can drain the manager, right? To keep manager off from taking the load. In Kubernetes, by default, your master will be off from taking the load. You will not run any pods on the master. But you might be asking, some time back default pods are there on master. Yes, default pods are allowed, but for any other pods you create, master, they'll not go to master. Master will be by default in the tainted state. Tainted is a far advanced concept in Kubernetes. Tainted means it is off from the load. Good. So everything, we have only one worker, obviously everything goes to worker node. And this is the IP address assigned to the pod from the range we have given. We have given some pod cider range in the beginning, right? So that's your pod. And I have deployed the pod with the imperative command. Imperative command means like this, a single line command. But this is not the practice we use for Kubernetes. This is useful only for certifications. Of course, in certification also, you need to write manifest files. Maybe if you want to do some things quickly, like in certification exam, some of the questions, you may go with this. But in real time, you will never do this. Rather, you will do it in a declarative approach through manifest files. Remember this thing from now onwards. Anything in Kubernetes can be done with this imperative command, single line commands. Like I told you in the beginning also, I don't remember whether I have told this batch or not. See, certification is like a competitive exam, right? You have some competitive exams for intermediate, right? Like MSET, NEET and all. The shortcuts you do and execute the task. That's where you have certification. But in practice, in reality, you write the manifest files. Of course, in certification also, there were many questions where you have to write manifest files. Okay, so rather than this, always rely on the manifest file. So I would say this is not the best approach. Kubernetes doesn't prefer this. Why? Okay, I'm deleting this. You may keep it also, no problem. But I'm deleting. Delete pod. Always delete type of the object. It's a pod object. Name of the object is sample. I'm cleaning up. And then we'll create with a declarative approach, which is the best approach. Why declarative approach is the best approach? Think about it and let me know.
We can save those configurations.
You can save them, you can reuse them, you will move them to version control systems like GitHub, you will maintain versions of it. Reusable, right? You keep modifying it, so you have versions of it. So that's the best practice. So I'm writing a manifest file in YAML. But how do I write manifest file? Should I know coding? It's absolutely not the coding. Okay, go to the Kubernetes official documentation. This is how you write the manifest files, either in the real world or in the exam also, in the certification test also. Kubernetes is an open book exam. Means they are not expecting you to write this manifest file by heart. Okay, in interviews also, you can have the permission to refer them. But of course, through practice, if you are not referring the document and writing it, means it shows your expertise. But of course, few parameters keep on changing. Definitely, we have to have a look at it. But through practice, you know this format well versed. You'll be well versed with this format. Okay. And also see, like I told you in certification or in interviews, it's open book exam. You have to refer only Kubernetes documentations like kubernetes.io, particularly in certification. In interview by mistake, if you open like it's always a communication. But here, yeah, in certification, of course, it's a way long for you to go for certification, but I'm just giving you some tips. Don't get overwhelmed. Okay, you are not taking certification now. Just I'm giving you some tips as we are in the learning path. So in certification, when you search like this, you will get so many links here, right? You should make sure you'll open only Kubernetes.io. In certification, by default, I mean, by mistake, not default, by mistake, if you open any other blogs, right, it is proctor monitored. So you will be blocked from the or expelled from the examination. Certification, Kubernetes certifications are very strict. So you should, that is also practice. Of course, the first ones will be Kubernetes only, but still make sure you are opening only Kubernetes.io pages, others not allowed. So here is the manifest file. Everything will be explained in here. Anyway, I'll explain, just copy this and place this manifest file here. See, first parameter API version is a mandatory. Okay, API version indicates the version of Kubernetes API v1 standard one. Then kind is pod. You are deploying a pod. Okay. Then metadata indicates gives you information about the pod, like name of your pod. I want to give name as sample pod. Then spec indicates what is inside the pod. What is inside the pod?
Containers.
Container. So name of your container and the image of the container. I mean image of your Docker image. I just want Nginx means it will use latest. And then the ports. Container port is port where your application is running. That's all, as simple as that. Again, I'll give you every object. We will be creating so many objects as we go by. Every object will have metadata. Every object will have metadata specifications. Metadata gives information about the object, like name. Okay, if you want, you can put some labels for identification. Specification indicates what is inside this. You have container. So container name, container image, port number, all of that will be dealt with specification. When you run that, a pod called sample will be created with a container in it, and the container name is Nginx, coming from Nginx tag latest image. That is the meaning of this manifest file. Always declarative approach is preferred, and Nginx runs on port 80. That's what is defined here. Writing a manifest file is very simple. People are under the misconception or under the impression because of some misguidance. Kubernetes needs coding. Is this coding? Do you think is this coding? Because we say we write manifest files in YAML. YAML is just a data serialization language. You represent the data in the form of key valued pairs. Actually, these are key valued pairs. Key assigned with some value. Right? That's a format. Already format is there, template is there, an official document. You take it and modify and understand those parameters. That is important. It's not that you need to write this line by line. Are we good?
Yes.
Yeah.
So let us save this. This is preferred because later on we push this manifest files to our GitHub repository. Now, how do you apply it? Any file, apply -f pod.yaml, apply command. Again, pod is created like earlier. The way you created before, this also same. But how you created is different. Both are same. Earlier also same pod. Here also pod is created. Configurations are same. But earlier one is called imperative approach. This is declarative approach, which is preferred in Kubernetes. In real time, we use this declarative approach only because you will never run imperative commands because you will not have direct connection to the cluster also. That is one thing. Another thing is if you keep on running commands, we don't have a history on which person run what command and all. Right? Of course, you will not have permissions on the cluster as well for you to run directly. So these are all the reasons. So cluster is created. If you want to see where it is running with output wide, we have only one worker node, obviously on the worker node only. See here, node worker node. If you want to see more details, kubectl describe pod. Okay, it will show you when you describe name, sample, node name, Okay, IP address, everything you can see. This is the IP address assigned by Calico plugin. Okay, container ID, image, pullable ID, some ID when it is pulling port numbers. And this is important. Do you remember the architecture? Scheduler will schedule the pod to the worker node. See, default scheduler successfully assigned sample pod to worker node 1. Then kubelet will get the instructions. Kubelet will pull the Docker image. Kubelet has pulled the image successfully in 1 second. Kubelet has started a container, created a container, container is started. Right? That's how each component work together. Architecture can be seen, like what happened can be seen under the events. That's the architecture we discussed. Correct? Following?
Yeah, Preeti, you
Hmm.
installed Calico network plugin. So why that is required? Because you already specified network range, right? While creating the cluster.
Network range is set. I have set the IP address range. That's all. We need this Calico plugin so that it will take care of assigning the IPs and communication. Who will assign the IPs? Or like they should communicate, right? On the top of it, you need to install Calico, some network plugin. Calico, flannels are there. We have installed Calico plugin.
Okay.
Which one will be used for production grade environments?
Which one will
Uh,
be used for production grade?
environment in the network plugin.
Network plugin depends on so many factors, okay? Again, each plugin has got their own features, right? That's all networking. That comes under Kubernetes architecture. Like Kubernetes architects will plan those things. Any plugin will work except certain features. Generally, Calico plugin we are using. Flannel also can be used. It's not that only this plugin should be used.
So Calico, you mean to say Calico will be supported by all kinds of Cisco switches?
Louder, please, louder. Your voice is not clear. Calico plugin
So
is supported.
all kinds of Cisco switches.
All kinds of Cisco
Cisco switches. Cisco switches. Switch.
switches.
Yes.
Cisco physical switch.
Yes.
Okay.
Why do we need a switch here?
Means it should support, sir. The protocol should support, right?
Oh, you mean for the connectivity? See,
Correct.
Kubernetes Kubernetes networking is different. Okay, it's not like you were talking about switches and all. Kubernetes networking is different. Kubernetes CNI is there. Okay, container networking interface. Providers are Flannel, Calico. It's again a deep subject. It's a different topic. Like I told you, Kubernetes architect will decide that level of thing. You can read your layer 2 networking layer. If you are into networking, you can read it, but this is not required for you. Okay, CNI comparison, why Flannel or why Calico. Here you see is developed by the Core OS is perhaps the most straightforward popular CNI. It is one of the most mature examples of networking fabric for container orchestration systems. Better inter-container, inter-hosting networking. Compared to some other options, Flannel is relatively install binary Flannel D and Flannel configures a layer 3 IP4 overlay network. Flannel is a good choice for administrative perspective. It offers simple networking model. Whereas popular Calico takes a more holistic view of networking concerning itself. So you just deep dive, read into it, you can understand better. It's saying network and Calico is known for advanced network features. Network policies is one of the most sought out after capabilities. Like there is something like network policies also, another object in Kubernetes. And again, Istio service mesh where communication can be controlled between the pods. For all of them, Calico is preferred. So it depends whether they want to use some service mesh like Istio, then they may go for Calico. So like that, each one has got their own features of its own. Accordingly, the plugin will be chosen. It's a vast topic which needs networking background as well. You don't need to get into it. But yeah, this is some idea how you can see deep dive into Kubernetes networking. This is not. Always go for the official one. Difference between load balance, this we will learn. Ingress capabilities also we will learn. Why it is showing this?
That is Rancher by SUSE. So it
Oh,
redirected
okay,
to
okay. I
SUSE.
opened a answer one. Okay.
Yeah.
So, if for networking or anything, refer the official pages. Okay, that is how the like it explains you how networking was made. It depends on layer 2, layer 3 based networking. First, you should know what is layer 2, layer 3 based networking and all. That gives you better clarity. For you, you don't need to get into it. Okay, whatever here, yeah, this one, you read the official page. No, this is not official page.
I think it is a plugin, so it is
Ah.
redirecting you for the SUSE page.
Correct. It's like a add-on, I told you, right? On top
Yes.
of the components we install. It was like an add-on which will help you take care of those network configurations. See, installing add-ons. It's like an add-on. Networking and network policy. Calico, right? Cilium is another one, right? So many other Flannel, so many network plugins. Do you see that? So which kind of networking they need, it depends. Accordingly, network plugin will be installed. You can read over this. You'll get an overview on what are all these things. But you don't need to get into this. Not required. Will not be a Kubernetes architect in the first step. It needs lot of experience. All right. So pod is created, right? Here I would say, okay, it's gone. Okay, pod is created, right? We have deployed the pod, but you want to scale the pods. Let's say now one pod is, and I want to run 100 pods, or else I want to, like it is running Nginx, I want to access from the browser, or else I want to implement rolling updates. We have learned, right? Later on, I want to implement rolling updates. How are all of that possible? Yeah. If you deploy this like this kind pod, if you want to scale, I have to repeat this section 10 times, 100 times, as many replicas I need. But I just want to do it in an effective way, a reliable way. How is that possible? Yeah. That's where again comes another deployment, another advanced deployment in an object in Kubernetes called deployment object. See, like I told you, kind is pod. Okay. Like you have kind deployment, service, and so on. So many objects are there. We'll be going through each one of them and see those like rolling updates, rollbacks, and all. We can stop here. You set up the cluster. Okay, follow the steps in the document carefully in the same order, exactly the same commands. Don't mess up with it because fixing the cluster would be a nightmare, particularly on-prem clusters. Don't mess up with them. If you want to practice the troubleshooting, do it at the end, because if you sit and troubleshoot now, it will never end. You start troubleshooting, experimenting the setups later. First, go through the steps exactly and set up the cluster and start the hands-on. Once you master them, later on you experiment the things. Got it right? So that is all for today. Once done, just stop them. Tomorrow you can again start and you still can work on your cluster as it is. Don't just leave them running.
Okay.
Any more questions?
Ma'am, as we did the port forwarding, I mean, the port of the container is being forwarded to the host port in order to access the application. Are we going to do the same here?
We will do that, but not in the same way. In Kubernetes, it is done differently, but the basic concept remains the same. We will do that.
Ma'am, you did send 1040. What it is done for?
Security in Linux is disabled. There is a component called SC Linux, security in Linux. For CentOS Red Hat based systems, we need to disable it for the nodes to communicate. That's what I did. So that your nodes can communicate. Any more queries?
Regarding Jenkins, I have a query.
Mm?
Can I? Can I?
Yes, what is the question?
See, you showed in the lab to add Linux as a Jenkins slave from the SSH keys, how it connected. But if I want to add a Windows as a Jenkins node, Windows machine as a Jenkins node, how the SSH means connectivity protocol will work?
You have to use another protocol to open the connection from master.
I want to, huh?
Another protocol is there to connect to the Windows, not the SSH protocol.
SSH is for Linux. What is in the Windows for this?
That's what I'm saying. JNLP, another protocol, JNLP protocol, Java
JN
Network Launch Protocol.
JNLP. Okay.
Mhm.
Okay.
In the drop down, like where you are selecting SSH, there'll be an option called Connect from Master. You have to select it and connect.
Mhm, mhm. Okay. So that will be a plugin for the Jenkins or how?
You will have the option by default, not ever required any plugins. Not.
Mhm.
Hi, Preethi.
Hello.
For connecting the phone, I'm getting the error.
Sorry?
I'm getting the error for connecting the instance for
Yeah, I
the
saw that one.
what I need to do for this.
Why are you getting this error?
No, suddenly
You can try
load.
connecting from PuTTY or terminal rather than connecting from the browser and check.
Okay.
It is just the connection error. You have to connect it properly. Try connecting from the PEM file. Have you used any PEM file there? Have you had any
No,
PEM file?
I'm connecting
Create
from
a key pair.
browser.
Whenever you create instance, create the instance with a key pair and download that key pair. Go to that location and start connecting. Till now, haven't you connected to any other instances?
I have connected, but
Mhm.
two is around the half connected, not to put it.
Okay, try connecting again from the terminal, from the location of the PEM file and see. All right then, thanks everyone. Have a good day. See you all tomorrow. Bye everyone.